Hi, in continuation with the first video now, let's go ahead and have one more demonstration. Employee ArrayList demo. You have an employee class which has got name and the salary as the attributes. You have a constructor and you have a toString method. You have test employee class over here. In this, what we have done is there are 5 employees which have been instantiated with reference names as E1 through up to E5. Then there are 2 lists which are declared. One list, ArrayList, that means employee ArrayList is initialized as new ArrayList of employees. Then next is linked that means it is the employee linked list which is initialized as new linked list. That means initially it is a blank linked list. There is no employee added into neither the ArrayList or linked list. Now what we will do is we will add E1 through up to E5 all these employees into an array list. Then we will add all employees E1 through up to E5 in the linked list. See now, the thing which I was supposed to see is an array list is the array at the backend which has got continuous memory to store its elements, and the linked list is a doubly linked list at the backend which has got the data, the previous node information and the next node information into it. You will find that it is exactly represented in that way. So just with the help of 1 or 2 steps, we are going to see that through debugging. So let's go to the option of debug. We have got a breakpoint initialized somewhere near E5. See, it's like the entire program is run up to E5. See, E1 has got name and salary. E2 has got name and salary. E3 has got name and salary. Remember these IDs, ID 17, ID 19, ID 21, ID 22, etc. And now when we go one statement further, we have E5 also with ID as 30. Okay, please remember these IDs. Then we have got the initialization of array list. With initialization of the array list, we have array list initialized. It said somewhere, you can refer to the book, chapter number 15, that when you initialize a blank array list, you've got an array list of 10 elements length. Let's look at that. This is the array list. Then you have got linked list, which is initialized. See, the linked list which is initialized has got ID equal to 49. Array list has got ID equal to 36. Now, one element which is E1 is getting added into the array list. See this, ID is 17. Over here, ID is 17. the first element as a reference got added. When we go ahead, the second element gets added. Then next, when we go ahead, the third element gets added. Then the fourth element gets added. Then finally the fifth element gets added. Again go back. See, it is the values. See, even through up to E5, please remember that even through up to E5, these IDs actually, which do correspond to certain memory location. That means the reference memory locations are stored under the array list at the element positions starting from index 0 through up to index 4. This you are supposed to remember. Now look at the linked list. We are going to go ahead. Same employee we are going to add into the linked list, but this time the memory is not continuous. And then you are going to see the previous and the next references stored along with the information of each employee. This is what I wanted you to see. See over here, the interpretation of fourth element is name and salary. Simple. There is no previous, there is no next. As such, reference stored besides the information about the employee. Over here, if I check it further, I'll find that I've got the name and the salary so far as the first index is concerned. When I say add E2, I've got name and salary. See, this is what I wanted you to see. See, this is something, show logical structure. So this logical structure is like this. And over here, if I click, this is what you get. And for this, the logical structure is item, next, previous. Okay, this is what I wanted you to observe. In a sense, it maintains at the back end a doubly linked list when you use the linked list as the ready-made class, and when you use ArrayList as a class, it maintains an array. Thank you.